Hello everyone. So in this video, we'll discuss another concept on backtracking that is related to N-Queen problem. So first of all, let us try to understand what is N-Queen problem. So in this problem, a chessboard that is a matrix of size n by n is given, and it is required to place the n number of queens on this chessboard with following constraints. So the constraint number one is that when you are placing a queen in a row, so there will be only one queen in that row. And similarly, there will be only one queen in the column. So no two queens should be in same row. No two queens should be in same column, and no two queens should be diagonally opposite. So, so basically, if you see this as a matrix, then it's very simple. Like if I take it as a 4 by 4 matrix, then only one queen in the row, one queen in the column, and no queens should be in the diagonally opposite locations. So why we are solving this problem using backtracking is just it's a simple reason that if any of the above constraint is not satisfied, then it is required to adjust the queens which are previously placed. So suppose there are four queens and you are trying to place q3, and there is a problem with q3 and the constraints are not handled, then it is necessary to adjust the position of q1 and q2. So let me show you one simple example. Like this is a 4 by 4 matrix, and in this 4 by 4 matrix we are required to place four queens q1, q2, q3 and q4. So our output array X will be of size 4, okay? And in this 4 location, we will be just writing the column number in which the particular queen is placed. For example, queen 1, queen 2, queen 3, and queen 4. So if we start with the first queen in the first row, then all these locations will be invalid because of the row and column constraint and as well as the diagonal constraint. So now you can see that when we are talking about managing the constraint, it is reducing the solution space. Like our solution space, which was of size 16, after placing one queen, remaining locations were 15. Now these three, and these three, 9 locations are not valid. So only you are having 6 possible locations available for placing the remaining three queens. Okay. So now I can keep Q2 here. And when I keep Q2 here, I will not be able to place Q3. So look at this problem. Here, the third row does not have any particular possible position. Okay. So just this is how the constraints are basically handled. Like if you can see this particular matrix, you will be able to understand that when we are placing Q1, then all these and all these are not possible. And when we are placing Q2, so you don't find any position for Q3. Okay. So how we proceed further? Like we can have another go at the same problem, and if I start with the second column, then all these locations are invalid because of the row and the column and the diagonal constraint. So I can place Q2 here, and this and this row is not valid. So I can place Q3 here, and then I can place Q4 here. So my solution X becomes 2, then 4, then 1 and 3. And this is my Q1, Q2, Q3, and Q4. Further, if I try to solve, so this is how the solution looks like. And if I just try one more solution on the same matrix by removing all this here. Uh, so what I will suggest, like you can just try one more solution by shifting Q1 from column 2 to column 3. Still, you will be able to solve this problem and will be able to find a solution. But one of the major observation here is, like if you are trying to place, suppose if you are trying to place a particular queen in one of these four position, then the corner positions must be avoided. So you cannot start placing Q1 either on the rightmost or on the leftmost corner. And if you do this, then you will not be able to solve the given problem. So the basic idea is, like when you're talking about placing the queens, then probably the first thing is to start placing the queen in either column number 2 or 3 or 4 or 5 and so on. But if it is 4 by 4, then either column 2 or column 3. Let me show you one more example here. Suppose we take a matrix of size 6 by 6. So these are the 6 rows, okay? 1, 2, 3, 4, 5, 6. And we have 6 columns here. So now, if you start placing the queen from the corner position, you will not be able to get the solution. But if you take one more uh, observation, then another observation is two queens cannot be placed in the adjacent column. Like if you are placing Q1 in column 2, Q2 cannot be placed in column 2. So you can place Q2 in column 4, okay? And 1, 2, 3, 4, 5, 6. So you can just skip this for some time. And then you can place the next queen, that is Q3 in column 6. So check this. This is a concept of clustering with even odd number. So if you take the solution X, that is our array, then 2, 4, 6. What we mean to say, Q1 in column 2, Q2 in column 4, and Q3 in column 6. So because of Q1, all this is blocked, okay, right? And this are all blocked. Because of Q2, all these are blocked, right? Because of Q3, you can see the cells which are blocked are like this, okay? And now you can have a Q4 at some position here. So this Q2 will block this, Q3 will block this, okay, upward also. And for Q4, you can have one position like this one, Q4, all this will be blocked, okay. Q5, one position like this, all this will be blocked. And then we have Q6. So it is 2, 4, 6 and 1, 3, 5. See the sequence. We are basically first using the even columns and then we are using the odd columns. So logically, it's one of the classical application of circular linked list. Since you are ending the column here at 6th position, you turn round and then you come to column 1 and then the column 3 and the column 5. So if you start with column 1, then it is very rare that you will get the solution. But if you start with column 2 or 3 or 4 or 5, then you will be able to get the solution. So 2, 4, 6 and 1, 3, 5 can be one solution for the 6 queen problem. Similarly, you can have another go, like you can try for some position like 3 and then 5 and then probably just going circular and checking whether there is another solution possible or not. So this is a brief discussion on this is a brief discussion about the n queen problem and how n queen problem can be solved. So we can just stop here and then I will continue with the